This lesson is going to focus on calculating percent error and percent change. Percent change describes how much a quantity has changed relative to its original amount. The percent change can be an increase or a decrease. There's a key percent change formula that we need to know to use to solve these problems. So percent change is equal to the final amount minus the initial amount divided by the initial amount. And since it's a percent, we're going to multiply that quotient by 100. Now, since it can be an increase or a decrease, if your percent change is a positive number, that means that we're going to have a percent increase because the final number is bigger than the initial number. If your percent change is a negative number, that means we're going to have a percent decrease. An alligator was 32 inches last year and is now 38 inches this year. What is the percent change of the alligator's length? So since we're looking for the percent change, using our formula, we're going to do the final number, which is what it is now, 38, minus the initial 32 inches, divided by the initial length of 32, times 100. 38 minus 32 is 6. So we have 6 over 32 times 100. 6 divided by 32 was 0.1875. And we multiply that by 100, we have 18.75%. So it is an 18.75% increase. And we know it's an increase because it went from 32 to 38, and we had a positive number when we found our percent change. Percent error describes the accuracy of a measured or estimated value compared to an actual value. Percent error will always be a positive percent. Another formula to know, very similar, but just using different words, is for percent error. So if percent error, since it's always positive, we're going to do the absolute value of the actual minus your estimated divided by the actual, since we're finding the accuracy compared to the actual value. And since it's a percent, we're going to multiply that by 100. The specification for a length of a bolt is 4.75 inches. A machinist makes a bolt that is 4.769 inches long. What is the percent error of the bolt's length? So since we're looking for percent error, we're going to use our formula that we just learned on percent error. So it's the absolute value of the actual, which is the 4.75, because that's what it should be, minus the estimated, which in this case is what the machinist made it to be, of the 4.769, divided by the actual of 4.75. And then we're going to multiply that quotient by 100 to make it a percent. 4.75 minus 4.769 is negative 0.019 divided by 4.75. Negative 0.19 divided by 4.75 is equal to negative 0.004 Now we're going to take the absolute value. So the absolute value of negative 0.004 is 0.004 and multiply that by 100. So we would have a 0.4% error. And it makes sense that our error is very small because the difference between them was only off by 0.19. So the closer your percent error is to 0, the closer the estimated value is to the actual value.